Hi everyone. This will be the last topic for your second semester in General Chemistry 2, and it's acids and bases. So, substances may be acidic, basic, or neutral. So, tulo ra na ang klase sa substances. Either it's acidic, basic, or neutral. So acids are, when dissolved in water, it will have a sour taste. Acids give a sharp sting on the skin and they react with metals na magnesium and aluminum, releasing hydrogen gas H2 indicated by the formation of bubbles. Acids turn blue litmus paper to red and colorless with phenolphthalein indicator. So if you're familiar with litmus paper, there are two types, the blue one and the red one. So to check if it's in acid, it when you soak it in acid, the blue litmus paper will turn to red. Okay? So, phenolphthalein, if it's an acid, the liquid will turn colorless. So, phenolphthalein is an indicator. So, it's a chemical which changes color depending on whether it meets an acid or a base. So, it turns purple if it meets basic, such as ammonia. It stays colorless if it's an acid like vinegar or neutral substances like water. So again, not all water are acids or neutral, okay? And not all water are bases. So bases, on the other hand, turn red litmus paper to blue and are pink in phenolphthalein. Okay? Ang acid kay colorless siya in phenolphthalein but are purple or pink in bases. So if you remember pH levels, if it's equal to 7, unsa ang equal to 7? So when it's equal to 7, it is neutral. If it's less than 7, pH levels less than 7, it's acidic. If it's greater than 7, then it's a base, or it's a basic. So Bronsted-Lowry, acids and bases. So Bronsted and Lowry are the scientists that are who uh, who came up with acids and bases. So acids and bases can be differentiated using Bronsted-Lowry or Lewis definitions, including Arrhenius, but we will focus with Bronsted-Lowry. So acid is a substance that can donate a proton. Unsa na proton? Hydrogen proton. While a base is any substance that can accept a proton. A hydrogen ion is a proton. Okay? So it's in H+. Remember that acid is a proton donor while base is a proton acceptor. If an acid can donate one hydrogen proton, it may be called monoprotic. If an acid can donate 2 hydrogen protons, it may be called diprotic. If an acid can donate 3 or more, it may be called polyprotic. Here's an example. We have HCl plus H2O. So HCl here is what? It's an acid because HCl will become Cl minus in the product phase. So, unsay nahitabo? Ni HCl kay gidonate niya kang water. That's why water here, H2O, is a base and will become H3O+. Okay, so HCl becomes Cl and H2O becomes H3O+. So here, saan ito? So si H3O can donate, again, sobra man niyang H, it becomes an acid and pwede siya makadonate. So H3O here becomes an acid while Cl is a base. So si Cl here can accept hydrogen proton. So acid is donor and base is acceptor. Sila i-accept sila i-donate or accept ang H+. H ra. So we have what we call conjugate pairs. What are conjugate pairs? These are pairs that are acid to base or base to acid. So, walay pair na acid to acid o base to base ha. It should be acid to base or base to acid in the reactant side. Also, in the product side, makakita pa conjugate pairs, of course. So, here the conjugate pairs are HCl. So, call lang reactants and products. HCl to Cl. We have acid to base and H2O to H3O. Base to acid. So these are our conjugate pairs. How about natay monoprotic na acid, right? Monoprotic acid here we have what? HCl in the reactant side. So, monoprotic acid in the reactant side is HCl. So, makadonate siya. HCl is capable to donate only one lang hydrogen proton. Hydrogen gas. So, here we have another example. This is acid. This is base. This is base. This is acid. So, note that HNO3 may nahimo siya og NO3 nawala iyang kay iyang gidonate. So the conjugate pairs are as follows. Okay. So monoprotic acid is HNO3. So it's similar to the first example actually. So for the second example, we have this. This is an acid. This is a base. This is a base. Base niya. And this is an acid. So H2SO4, ni-donate siya og isa, 2H2O, nahimo na lang siya HSO4 minus. So H2SO4 2 are conjugate pairs. HSO4 and H2O to H3O+. So we have a diprotic acid here because H2SO4 can donate to duha ka buok iyang H na pwede ma-donate. So this is a diprotic acid, H2SO4. This is an acid base. base, and acid. The conjugate pairs are as follows. So this is still a monoprotic acid, HSO4 minus. Again, here, look closely. So this is what? The NH3 here became NH4. So this is actually a base. And the H2O here is the acid. Because, kung inyong itanawon, nahimo na siya OH minus, right? Look closely, si acid, si H2O, nag-donate og hydrogen. Nahimo siya nag-donate siya ni NH3, nahimong NH4. And in the product, si H2O, OH na lang, OH minus. So the conjugate pairs are H2O, OH minus, acid to base nga pair. Right? Then, what? Base to acid nga pair. It should be NH3, NH4. NH4 plus. That's our conjugate pairs. So what do we have? We have what? Diprotic acid. Because ayaw tanawang NH3 ha, because that's a base. Wala man tayo diprotic base, only acids. So diprotic acid is H2O. And that's it. This is the final coverage for our fourth long quiz for this semester.